Well, welcome everyone to coming to our today's talk. We're the last thing keeping you from lunch, so we'll try to be timely. I'm John Rodriguez, and I work on the client platform team at Duolingo.
I'm Johnny Yi. I work on the animation accelerator team at Duolingo.
And today we're going to be talking about how Duolingo has been experimenting with KMP to help bolster developer productivity. But first, a brief history. Since it was founded in 2011, Duolingo's mission has been to develop the best education in the world and make it universally available. Around June of 2012, this mission began when Duolingo first launched, starting with its web platform. In the next 12 months, the iOS app was released, followed by the Android app. Now, since then, the company has been scaling slowly from a handful of mobile engineers to now a little over 100 across iOS and Android. As a result, we now have a mobile org comprised of several feature teams, very similar to other companies. And we've started the early formation of a client platform team, things like client architecture, stability and performance, and app mobile-specific build systems have now been included in all this as we try to scale up for the next generation. The app has also seen considerable design change, the most notable of which happened in 2022, nearly 10 years after the mobile apps initially launched, when the home screen transitioned from the tree-like structure to what's commonly called the path. If you've ever used Duolingo, you've likely noticed that it incorporates game-like features to make learning more engaging. Accomplishing that, along with the pace with which we go from prototype to feature launch, has led us to explore technologies which accelerate that, with a particular focus on cross-platform technologies so that we can write it once and run it on multiple platforms. To paint that picture, we've experimented with React Native and Flutter, two well-known mobile frameworks. We've even dabbled in Unity and Godot to see whether game engines might help us accelerate that development. For animations, we've had great success moving from Lottie's linear animation system to Rive, a state-driven interactive animation system. We'll be talking more about Rive in this talk. But getting to the point, on November 2023, JetBrains announced that KMP is stable and production ready. And so this is where we begin our KMP journey. The first thing we had to ask ourselves was, what makes a good module for KMP? Well, first, we wanted something that was stable. And what we mean by that is the value of the module is clearly understood. Interfaces are not changing too much. The requirements are well known. And for the most part, yes, we'll change some things, but for the long term, we know it'll be roughly the same form. We'll see an example of how math grading was a great example of that. Secondly, a good candidate for a module are cases where platform implementations have already kind of diverged and weren't consistent with each other. This results in weird quirks in behavior, missing functionality entirely. Odd bugs QA will say, hey, this is a bug, but it's only on iOS, why? And we have to answer that. So it's just nice to kind of commonalize all those bugs in one place. Also, things that are business logic, data-driven, network-driven, think of your analytics libraries, are great candidates. For context, when we started dabbling in, Compose Multiplatform hadn't been stable yet, and so we were not really focusing on the UI portion yet. And then finally, a thing that makes a good module for us was where the boundaries are clear, there's an immediate understanding, and there's little debate on what's in scope. Think of like feature flags, things that are cohesive in general. Now, one bit of context that's important to know is that at Duolingo, we're very data-driven. And as a result, we rely heavily on A/B/N tests, which allow us to test over N conditions to find which one's most effective. For example, today, we are currently running 300 experiments in production. Now, given the rubric we just mentioned, the first area we then decided to explore was consolidating the infra code that manages how we conduct experiments in our mobile apps. We chose experiments because the infra was made up of a small set of stable interfaces, as I mentioned, with limited blast radius that would benefit from having a single implementation on both clients. Similar to mobile release best practice, we also use stage rollouts in our experiment infra, typically starting at around 1%. Let's suppose you want to run an experiment on new users or, say, US users. One way to do this is with a criteria, which will define which users will be in the experiment. If a user is not eligible, they will not be treated. They'll see the control fallback condition, i.e. what's already existing in the app, and they will not be considered for the analysis. If you are the experiment, not only because you satisfied the criteria, but also you're in the rollout percentage, you are considered eligible, and therefore that will dictate what condition you see. If you're an ABN, this could be many conditions. Finally, treat it as the cache state. Once you're assigned to a bucket being eligible and applied to a condition, that's where you're locked into. One little nuanced thing is sometimes there are particular experiments that we want to gate at a certain point. So a good example is if the backend wants to know whether it should include a new challenge type in a lesson, if the user fails a lesson before reaching that challenge, we don't want to include that in our analysis. That just would muddy up the data. And so we add this thing context where the backend contents will signal that it's not ready for analysis. And then once we get the user to work on that challenge type and proceed forward in the flow, we'll now include them in the analysis portion. Okay, so that was a brief introduction of how we ran experiments. We'll see that the code on Swift is pretty identical, yeah? Whereas an experiment record is the state of a given experiment, the treatment update represents a change in that state. And so on iOS, we have a similar structure, but now you can start to see some implementation divergence. One of the areas with the most divergence was network client. On Android, we already anticipated moving to KMP on some point, and so we used KTOR and OKHTP to update experiments to a given treatment. And on iOS, we were using a custom network client backed by NSURL connection to do the same thing, as is very commonplace. So how do we design this? Well, the backend engineer who took on this initiative thought that starting with the file system would be a good place, and so created platform-specific elements to handle that. Today, we probably use OKIO Multiplatform. From here, we used a FIFO persistent queue. The idea being is that multiple experiments may be going on in one single navigation flow. And so we didn't want to fire them off one by one to the server and DDoS our own systems. So we batched them up on disk and eventually, at a timely basis, upload them. We used open source libraries that were vetted at the time, KTOR, of course, being the canonical network client for multi-platform, and Kotlin serialization for the JSON parsing. For the more complicated pieces of platform code, we didn't want to refactor the entire app to accommodate, so we had thin interfaces to wrap some of the platform details that were already kind of part of the core app and injected those into the lib. And so a clean boundary from the KMP lib to say our authentication module and our user profile stuff was a nice way to kind of separate that. Now, I have some bad news. Unfortunately, this project did not ship due to team shifts and internal priorities and timelines. But given that this was the first project, there was a huge amount of value in paying that explorer's tax. In this initial experiment, we learned how to design API boundaries for clients to work with, and most importantly, began to understand what the iOS experience would look like. As Android developers, we take for granted just publishing an artifact to Maven Central and consuming it in our apps pretty easily and individually. On iOS, we quickly realized that packaging a Kotlin runtime per library is not a great idea. And so we developed something internally called an umbrella project so that we can statically link it to a single XC framework. Also, the experiences that we've all shared over time of not being able to debug on the iOS side and common pain points were also surfaced during this process. And so again, while we didn't ship this project, huge learnings were undertaken. These lessons learned were enough assurance and optimism for our next KMP undertaking, Adventures. And I'll now hand this over to Johnny, the lead for that initiative, to talk more about that.
All right, thanks, John. So you might remember our requirements from before for what makes a good module for KMP. One thing we realized is that Duolingo is a really delightful app, and we have very visual features, so we ended up getting rid of the no UI requirement. And with that, let me start talking about some of our animation technology that we use at Duolingo. We use a system called Rive, which allows us to get dynamic real-time vector graphics into our iOS and Android apps. They have an editor where we can design and animate these assets, and then we export the file as their own custom .riv file format, which we then feed into their open source runtimes, and this lets us load in the assets on both iOS and Android. So this is what a Rive file looks like. We can programmatically control these at runtime. You can see that as I click on the different inputs and fire those inputs, the animation state updates and it plays the associated animations. There's even built-in interaction handlers. So for instance, if you tap on Junior, there will be a specific animation that plays with that as well. I won't go into too much stuff here, but if you want to learn more about how we use cross-platform animations with Rive, you can check out Judy Lin's talk last year at JoyCon, New York City. So, hopping right back into adventures. Adventures are these super immersive mini-games for language learning. You play as one of our road characters, and you sort of walk around and talk to different characters, trying to solve real-world scenarios, and really put yourself into that scenario. It's heavily interactive. Pretty much everything on the screen is tappable, and it's very visual. Every single asset here, save for the X button at the top left, is a Rive asset and has associated animations on it. So you might be thinking, why use KMP to build this feature? So at the time of us looking into KMP, Android had already built adventures natively, and we mostly wanted to have an iOS port for the feature. We thought it would be easier to convert the game logic into KMP from the Android code rather than from Android to Swift code, since it's already all written in Kotlin. Given the experiments lib exploration that John talked about, we had a lot more confidence as well that we could make KMP work within our mobile infrastructure. And probably the most important part was that engineering leadership was invested in multi-platform technologies, and even more importantly, the engineers on our team had a personal interest in using KMP as well. So the engineers knew that we wanted to use KMP, but how do we really convince others that that's a good idea? For product-side stakeholders, we had a very common business reason to give to them. It was that by reusing a lot of code, we would have a lot of engineering time savings, and we really made sure to emphasize that since it's a bit of a new technology, this might not be true for the initial port to iOS, but for any future features, it would save us a lot of duplicating code. We also had to convince other iOS devs that it was worth trying as well. And to do so, we spent 2 time-boxed weeks rapidly prototyping a hacky KMP library to get a minimal version of adventures running in the iOS app. This was easy to do now, given that a lot of infrastructure and the Umbrella project was set up from the experiments exploration. And by having this prototype, that really went a long way to convincing iOS engineers that this was actually technically feasible. So everyone was on board with KMP, and the next step was to really design this infrastructure. The key thing here that was hard for us was really trying to find the perfect line to draw between the native code, which you can see in the orange, and the Kotlin code, which you can see in purple. So a few of the elements to give a bit more detail. We have a repository that fetches and loads our Rive files. It uses OKIO. The biggest part of our library is our state engine, which powers almost all of the game logic within the adventures experience. And additionally, we even do a bit of UI logic as well within our screen grid helper class. And so, after designing it, we had a much more in detail spec, but we implemented it. And I'll deep dive a bit more into how some of that functionality actually looks like in code. So, the main class is Adventure State Engine, and it uses this mutable state flow to expose a monolithic game state, which contains all of the info that is needed by the native side to play any audio or animations that we want. To go more specific into one specific example, let's look at walking, which is very simple. You click on the screen, and your character should be walking to wherever you click on. So the first step, the user taps on a point on the screen. In this example, the user is tapping at a top left tile. We then go into another function within the engine, which is called on-scene touch event, which is basically used anytime the screen is touched. On the native side in iOS, this is Swift code, we simply connect this to a UI long press gesture recognizer. We take in the event from that, convert it to our custom KMP implemented grid touch event, and use that to call the method on our engine. When that is called, we have a bunch of game logic trying to make sure that the user is in a game state where the player is allowed to walk. And then eventually this calls a function, in this case, called walkCharacter2, which finds the best path for the character and sets that new best path within the game state. And then we end up with this. So we have our character, we know where he should go, and we have a path that he should walk along. But we still need to make him traverse this path and animate that as well. So how do we do this? Another key part of our engine is an on-frame refresh function. This gets called on every frame refresh, and it is sort of our step function. It can be connected to a CAD display link on the iOS side or a choreographer on the Android side. And essentially what each of the functions in there does is it updates the state on every frame refresh. In the walking example, it looks at the existing path, looks at the character's existing position, and based on the elapsed amount of time, does a bunch of math and figures out where the character should be next. And with that, we have walking. This paradigm was incredibly extendable to other features as well. We use it for conversations where, as you can see, the text is getting highlighted while Falstaff speaks. This is done in a similar way with an animate speech bubble function, where on every frame refresh, we calculate the exact span of words which should be highlighted. We're able to do other animations as well. For example, here we have a camera animation. We move the object to make it look like Eddie is pushing the cart. And we mostly just got all of our game logic within this adventure state engine paradigm. But we didn't just stop there. We also moved some view layer logic to KMP as well. And it's not really doing any actual UI, but more so handling UI state. We have a screen grid helper class, which calculates the bounding boxes of the objects. And then on the native side, all we simply need to do is pass in grid coordinates, pointing out what grid the character should stand on or object should be at, and we can simply just set the frame of the object to the rectangle that is calculated within the KMP library. So this all went really well for us, but we definitely didn't find elegant solutions in all cases. One big thing for us was coroutines use on iOS was difficult, and we really struggled to figure out a good way to handle this. We ended up copying this wrapper class from a JetBrains example, which ended up letting us expose the flow as a published variable on the iOS side. We also had some challenges with lacking libraries and some functionalities that are better built out elsewhere. One example is we needed a priority queue for our pathfinding algorithm, but we didn't really want to add too many dependencies, so we ended up creating one from scratch. But overall, we were very pleased with the results of our iOS Adventures experiment. One of our biggest worries going into this project was performance, and especially since we hadn't used KMP for something so animated before, we would worry that it would come with performance issues. And we were incredibly happy when we found out in our experiment that the performance of Adventures on iOS was on par with the performance of the rest of the iOS app, which was really exciting for us since it's such an animated experience. And we were able to speed up development a lot through the KMP library for future feature iterations, and we're happy to find that iOS engineers, Android engineers, and even a lot of our interns were able to hop into the KMP library and work on it as well. And finally, we also worked on a web port of Adventures. First step for this was adding a JS export annotator everywhere. We needed to expose all of our data structures as well as our engine and our repository, so this had to be added in a lot of places. We couldn't really find a clean way to work with our coroutines flow on web, and we ended up holding a state variable that the web library periodically read from, kind of destroying that reactive paradigm, but we were able to make it work in a performant way just because web is a bit more forgiving. Overall, for our timeline, the initial native implementation of Adventures took 9 months on Android. We spent 5 months really figuring out how to put this into KMP and building that iOS layer on top of it. And then finally, with the KMP library built out, it was just 1.5 more months to get the web port working. And to clarify, these are engineering months, so a sum of all engineering time. So with the success of adventures using KMP, one of our engineers started working on a different project called Video Call and ended up bringing KMP to Video Call as well. So what is Video Call?
Let's talk about me now.
So Video Call is our AI speaking feature where you can talk to Lily and Lily talks back. It's all 100% in your learning language. We built this on iOS first, and eventually we started looking towards an Android port, and we also wanted to communicate with the backend with WebSockets. So we thought it was a good time to start working on KMP library to implement this. One big thing to note here is that since WebSockets was new functionality, this was really the first instance of creating a KMP library to handle new functionality instead of just porting over existing behavior. So the library contains a lot of networking logic, and the brunt of it is in this video call session class, where we have all of these methods for all kinds of parts of a video call session, such as creation, when the user interrupts Lily or playing TTS. If we look at the interruption a bit more in detail, within the video call session class, we have a WebSocket session manager, and we use that to send a message to the backend. On the iOS side, it's a very clean interface. All we need to do is instantiate a video call session class, and then we simply call the method and pass our interruption event into that method. One of the really good things that came out of this library was we made a lot of process improvements in how we work on KMP at Duolingo. We ended up getting a lot cleaner code in this process. One big thing that we did was add Objective-C name annotations everywhere, which got rid of a lot of our naming conflicts and really helped make our naming more intuitive for iOS engineers. And we also made a lot of improvements in our build process as well. We automated a lot of the steps that we ran manually while we were working on adventures and experiments. Finally, since Video Call was a bigger team, we managed to get a lot more insight into what the dev experience was like for working on KMP. Unfortunately, we found that the library ended up being mostly maintained by Android engineers. There was just a bit more of a learning curve for iOS engineers since it is in Kotlin, and iOS engineers sometimes would, but were generally more reluctant to work on the library. Backend engineers were quite pleased with having a KMP library. One backend engineer said that it was much easier to debug issues since now there was only one source of truth for communication with the backend. So there's no longer a need to dig through two native code bases to try to figure out what's going on each code base. Back to the timeline for this, the iOS native implementation for the video call took 9 months. We managed to get WebSockets on KMP within 1 month, and then the faux Android port took 6 engineering months after that. So after we finished up video call, our engineers started looking at using KMP for some of our newer courses, and John will talk more about that.
Thanks, Johnny. So up until now, you may have been familiar with Duolingo as a language learning app, but did you know you can also learn math? After initially launching as a separate app in late 2022, it was eventually integrated into the flagship app along with music by the end of the 2023 cycle. Around this time, as Johnny mentioned, the math team also caught the KMP bug and began exploring ways on how to use it. They landed on sharing the complicated grading logic that had been previously duplicated across both clients. We offer a wide variety of math exercises, but at the end of the day, we really just want to know, did we get the answer right? If not, what would be a helpful message that we can give the user so that we can answer correctly next time? This logic is complicated and duplicated about both clients, so how can we consolidate that? For example, here's a math exercise where we place a point on a grid. The implementation for this challenge is quite simple, as there's really only one right answer. You either get the point on the grid or you do not. And so the grading for this type of exercise is just a simple equality check. But say now you are given a polygon and you need to calculate area or manipulate it on a graph. Well, since you're looking at different coordinate points and you care about the relative difference between those 2 points, you have to, basically there are multiple answers that could all be correct or within some tolerance of correct. And so the grading for polygons, for example, will be a lot more complicated. And in fact, I omitted on this slide. One interesting thing to dig in is a more complicated exercise we call factor tree. Here's how it looks. That was a quick animation. Let me go back there. And so you can see that there are some selected tiles at the bottom, and the user has to choose as many as there are open slots in the tree above it. And so this is dividing and finding your common factors. And so this is all backed by a Rive asset, as Johnny has alluded to earlier. And so here's an example where we're kind of using Rive not only as the UI, but also the presenter, where we're pulling state out of it. And so grading here, as you saw, there were 2 slots, and therefore you have to answer 2 different things. You're correct only if you get both correct. That's the simple case. You have to map the indices of the tiles to the indices of the tree. But what happens if you didn't get both correct and you only got 1 correct? Well, you want helpful feedback on which one you got wrong and kind of infer that way. But given the way that the tree is structured, you will not get correct credit for the second level if you got the first one incorrect, and nor would it be helpful to send you feedback for that. And so that's all included in the feedback message calculation for this screen. Overall, the grading library took about 1.5 months to build out. There was obviously no UI backing that. It was purely business logic and really deduplicating a lot of efforts. It took 1 engineering week to backport that then to iOS, and another week to backport it to Android. Now, one thing to mention is that this was partially shipped on iOS and Android. Part of the reason for that is we focused on only having the new challenge types that math is coming up with to use this grading library. Older challenges may be migrated if the need arises, but currently we have a lot of other work going on in math that has recently structured grading to be slightly different. And so we will revisit this, but for the moment, we're okay with just partially shipping this library. About the same time, another one of our new subjects was underway, chess. You might have seen the social media buzz around it. It's currently on iOS only, with Android shipping soon. It's our most recent course, and one of our math engineers on Android moved over to this team just after, well, not just after iOS dev had already begun. And so for now, iOS is fully native. But the Android team has been shaping a KMP lib to eventually drive both. Bringing that enthusiasm from math grading and hearing how well Video Call and Adventures had some great wins, the team really decided to double down on even more Rive and more KMP. This is our largest project combining these initiatives to date. Similar to Adventures, the KMP library manages the state of the scene. In this case, the state of the chess game, keeping track of a user's move for later review and updating the set of valid moves for a given piece based on a previous move. Bridge methods are then provided for the mobile clients. For example, given an algebraic chess notation, such as A1 to A3, transform that into the appropriate move logic, which will later drive the piece along the board. The chess team has been experimenting with the use case design pattern. Here we use it to set the initial game state, and then interactions with that Rive asset, such as moving a piece, will call back into the state engine to update the game state appropriately. Again, copying from the examples learned from the Adventures team. Here's a quick demo.
Try to finish the game by trapping my...
On iOS, this took 20 engineering months. Not 20 months, 20 engineering months. And mainly it was because teams were onboarding or finishing previous efforts. So this really kind of broke down to 2 engineers for 4 months and then added 2 more engineers for an additional 3 months. So 7 of actual clock time. To extract this into a KMP library then took a month. And the work on Android took 12 months, again layered. 1 engineer for 1 month, 2 engineers for another month, 3 engineers for 3 months. This was not for the KMP portion, but a lot of the challenges have to be integrated into this path. And so because chess is different from language learning or music or math, we have to figure out innovative ways to still incorporate some of that thing onto the path. And so these markers indicate where that experience lives today. And now, we're going to take it back to Johnny, who's going to dive into something special he's been working on.
Cool. So let's dive into Maker. And before we get deep into that, I want to mention that Throughout the past few projects, you might be thinking, why are these guys writing native code and then just using a KMP library for ports? It's sort of duplicating work that really only needed to be written once. And we completely agree with that. So through our past KMP experiences and explorations, we gained a ton of trust in technology, and now we know that we can still move fast while starting with KMP code. We've started to go KMP first for our features, and Maker is really the first instance of that happening. So what is Maker? It's this stream of work that we have for enabling more modular animations. We have a script, which you can see on the left-hand side, where we define everything that we want to happen in a video. And then on the right-hand side, we have a video that we can preview and then download as an MP4. It's this internal tool. And the tool will compose our Arrive assets, generate the audio, and compose them all within one single video. If you use our app, you may have seen a lot of ads using this technology, and if you follow us on TikTok or Instagram, you've probably seen a lot more videos in the past few months with characters talking to you. Here's an example of an ad that we're particularly proud of.
Unlimited energy. No ads. Personalized practice. Unlock the fast, focused learner within. Super Duolingo.
So we love this technology. But even though we love it, it still wasn't perfect. We were delivering these large MP4 files to our mobile clients, and in order to keep the files small, we had to do a lot of compression, which would often create weird artifacts or some pixelation within the videos. And these issues were really apparent on larger devices like iPads. So we thought, since we're just composing Rive assets and audio together anyways, why can't we just have Rive assets and audio and send a JSON file defining how these need to be rendered, and just send that to the client. And so we started getting to work on KMP library for Maker. Given the success of Adventures, we wanted to follow that architecture as closely as possible, since in both cases it's rendering a composition of Rive assets on the screen. We deliver the assets in a list of events to the client, and once the start time for the event has passed, using the same on-frame refresh paradigm that we had before, we trigger state updates. For the super simple case of updating a subtitle, we just update that within the state once that event occurs. And then on the iOS side, we check for the state update, and once that state update occurs, we trigger the necessary Rive animations to update our subtitle. This was incredibly successful for us, and we've been able to speed up projects like our new video call tab, which you may have seen, where there's a video where Lily tries to convince you to talk to her.
Hey, I'm stuck at the mall and so bored. Let's practice speaking Spanish. It'll be fun and low pressure. I can't stand pressure or the mall. Call me back if you want to talk.
So this audio references both the language that the user is learning, and Lily also needs to speak in the learner's UI language. So for each language pair, we have to create a new version of the video, which ended up being over 180 versions of this. By moving towards Rive assets and JSON files that define the audio, we're able to build this in a much more scalable way than if we used MP4 files. We're also excited about how we're able to more easily integrate this content into our UI by moving away from MP4 files. One example of that is here.
We'll remind you 2 days before your trial ends.
Where we can easily integrate Oscar into our UI. Another thing we've been working on and are excited about with the move towards Rive assets is just the possibility of a lot more interaction and haptics and a much better experience. We can even take advantage of the built-in interactivity within Rive assets for this, and here is an interactive ad that's a good example of this.
Behold, a surprise for you. Care to open it? Ooh la la! It's a free trial of Super!
And so, Given that we already had KMP experience and a lot more experience working with these technologies, we were able to implement the library in just 1 engineering month. And then following up on that, the iOS port just took 2 weeks to build the native layer on top of it, and then the Android only took 1 additional week to build. And I'll play one last maker-style video before John takes over to give a recap.
As you can see, KMP has played a huge part in crafting some of our most delightful experiences. But we're not done yet. Next, we'll talk about the future of KMP at Duolingo.
Thanks, Junior. So let's recap. So far, we've done 6 different KMP initiatives, starting from the experiments lib that ultimately did not ship, but was the Explorer's Tax project. We learned about iOS builds in general and learning how to form those API boundaries. We then jumped into the deep end of the pool with Adventures, where there's a lot of robust animation and UI states, used it for video call to manage WebSockets, simplified our grading logic on math, went even more in on the UI to experience the chess experience will be coming out soon on Android, and then the Maker project, which has been not only helpful for ads embedded in the mobile client, but also for some of our social media marketing teams. You can see that the various curves of adoption on iOS and Android favors a lot of the iOS adopting things, but leaning on Android experience. And we're hoping to embrace our iOS team more and get them more included so that we can ship to that KMP first strategy. And again, Maker was KMP first, and so a lot of the lessons learned there will influence that. One exciting trend for us is that the more that we use KMP internally, the more we find ourselves speeding up in terms of shipping. It turns out after you learn something, you get really good at it. And so easily getting buy-in on KMP features where product managers are like, oh, I don't know, will we be able to ship this in time? Now there's a lot more confidence behind it, and we're building up that knowledge. Being present at this conference and engaging with JetBrains staff has been also helpful for that. So while KMP didn't provide immediate value for us from a shipping perspective, we feel like it's become more impactful. So what's next? As I mentioned already, we're going to start an H2 defining a KMP first strategy across all of mobile. That's part of the client platform team initiative. And then based on the keynote, we're really champing at the bit to finally use Compose Multiplatform now that it's stable. We still like Rive for some of those state-based animations, as you saw, but we have a design system for a lot of static components and the challenges that you've probably seen, such as the areas where you'll select a token when you're completing a sentence for a language. And some of that stuff could be driven altogether. Of course, this wouldn't be a conference talk about talking a little bit about AI. We've been using a lot of AI at Duolingo. If you follow the company on social media or LinkedIn, you'll know that our CEO is really excited to see the potential for AI. We've been using Cursor and Copilot and Codex and ChatGPT. We've been using AI to generate some of the missing gaps in our language matrix. So we have a matrix of from your native tongue to the language that you want to learn. And it tends to bias towards non-English speakers wanting to learn English. And there's also plenty of languages around the world that we hadn't support. Generating AI, using AI to generate some of that curriculum has started to plug in those holes in that matrix so that we can offer even more languages to even more people. For the KMP side, in a hackathon, an engineer recently prototyped converting our Android localization library to be KMP compatible. They then used this on iOS to replace the native library they were using, and it all took them 2 days. On top of that, math has been really doubling down on AI recently, and if you want to learn more about that, because it hasn't shipped yet, Judy will be back at DroidCon New York in 2025 to talk about how they're using AI in Android development at Duolingo. Check it out. And with that, thank you.